In part one of this video, we talked about how Draper's inertial guidance system helped astronauts figure out where they were in space. In this video, we're going to talk about how the inertial platform worked to do just that.
We choose to go to the moon.
The inertial platform was a key element in Draper's inertial guidance system. And in the last video, we talked about how it remained motionless no matter how much the rocket moved or rotated on any of its three axes. It also measured the speed and the direction of the spacecraft. So, how does it remain motionless? Check this out. If you look at this simple diagram, you can see that the platform is nested inside a framework of gimbals, an inner gimbal and an outer gimbal. Gimbals are pivoted supports that allow rotation about a single axis. The outermost gimbal is attached to the frame of the spacecraft. So you can see, no matter how much the spacecraft rotates around any axis, the platform remains motionless. And as the spacecraft changes its orientation, its movement can now be measured by the angles of the gimbals, and that information is sent to the onboard computer. This allowed astronauts to always know the direction they were going. But how did it measure speed? So the way it measured speed was using something called accelerometers. And these accelerometers can measure increases and decreases in velocity. For example, if you are in a car that is driving along at a steady 20 miles per hour, you will not notice any change in velocity. The velocity remains the same. But if the car suddenly accelerates to 40 miles per hour, you will feel that sudden change in velocity until the car is moving along steadily at 40 miles per hour. And if the car suddenly brakes and the speed is reduced to 20 miles per hour, you will feel that deceleration. So accelerometers in a spacecraft will measure both acceleration and deceleration on all three axes. So with the information provided by the accelerometers and the inertial platform, the Apollo guidance computer can tell them exactly in which direction they're facing and how fast they're going. So they will know exactly what they need to do to get to where they want to go, which, as we know, was the moon.